Good morning, esteemed guests. Good morning, members of the board, colleagues and professors. I thank you for your interest in my work. I'd like to start by introducing myself. My name is Asmaa Benzmane. I am a PhD student at the University Hassan II Faculty of Sciences in Souq in Casablanca under the supervision of Professor Hasna Chamlal, and I would like to talk to you today about some of our findings in a study we did on interaction screening. The theme I am pleased to present to you is the interaction screening algorithm for a category of ultra-high dimensional regression models. I have divided my presentation into 4 parts. In the first part, I will introduce the subject of this communication. In the second part, I will give an overview of the Kendall Interaction Filter method proposed by Benzmane and his collaborators and the details of our algorithm. In the next section, I will give some practical examples, and in the last part, we will conclude. Let's start. Throughout this talk, we consider the following model, where xkxl is qualified as a significance interaction if its regression coefficient gamma kl is different from 0. Feature screening tends to become a necessary step for ultra-high dimensional data analysis and predictive modeling. It aims to select only relevant variables from a large set of features. There are 2 components of feature screening: marginal effect screening and interaction screening. In this work, we focus on the last one, which aims to select pairs of features that interact and together import useful information. And it's widely used in genetics because identifying the interaction between genes can improve the understanding of some rare diseases. My goal is to present to you a new technique of interaction screening in the case of regression models, and which uses the Kendall Interaction Filter. You may have wondered, what is the Kendall Interaction Filter? That's what we will see in the first part of this communication. Let us now move on to the first part, which is, as I said earlier, the methodology of our approach. We begin by introducing the KEF method. The main goal of this method is to select couples whose joint behavior differs from one class to another based on their interaction with respect to the response variable y. The coefficient proposed for this purpose is given by this expression, and its empirical version is given by this expression. The set of interactive couples is the set of indices GL such that f of y given x functionally depends on xgxl rank association, and its empirical version is given by this expression. However, despite its good behavior, the Kendall Interaction Filter has been dedicated to multi-class classification problems. It is therefore natural to ask, what is its extension for continuous response variables? We therefore opt for a slicing fusion procedure to transform the continuous variable into a categorical variable, then apply the KEF procedure. We consider the same regression model presented in 1 and assume that we have a matrix X of n rows, p columns, such that p is much larger than n, and a continuous response variable y. The first step of our procedure is the slicing step. We begin by defining n partitions pi as this first expression. Then we partition the observed data of the response y into slices according to the n different partitions using the quantile method. And we adapt the KEF measure to our transformed data. The new measure for each fixed partition pi is given by expression 3. Now we move to the second step, which is the fusion step that consists of summing the n measures found in the previous step. The resulted measure is given by 4, and its empirical version is given by 5. The set of selected interactive pairs of features by our approach is given by expression 6, and its empirical version is defined as the set of indices gk such that the empirical version of omega gk nu is superior than c times n raised to the power of minus r, such that c and r are positive constants. Now let us move on to our algorithm, which consists of 6 steps. First of all, step 1 consists in loading the input data. Step 2, the initialization of the selected indices set and its size r. Step 3 is the slicing step. Step 4 is the fusion step. Then step 5 concerns the selection of interactive pairs of features, and in the final step, we have the selected indices set. I would like to mention that we have performed our algorithm in R. Furthermore, our approach enjoys the sure screening property. To evaluate the performance of our algorithm, we consider 3 scenarios of simulations. We replicate each simulation 100 times and we compute the frequency of the supposedly interactive pairs. In the first one, we consider this regression model with n equal to 100, p equal to 500, and we compute the frequencies of replicates selecting interactive couples using our algorithm and GCS method that was proposed for interaction screening by Riss and his collaborators. Knowing from the expression of the model for this simulation scenario that the index of the important couple is 1, 2, the results show the good performance of the two approaches with this simulated data. In the second simulation, we consider this regression model, and here we compare the scores of pairs x1, x2, and x3, x4 to the maximum score of other pairs of features using a violent plot. The visualization shows the good performance of our approach with this simulated data. In simulation number 3, we consider this model, and for the two methods, we find the frequency of selecting the interactive pair x1, x6 equal to 1. This asserts the good behavior of our algorithm with this type of data. To sum up, our procedure has been demonstrated in implementation and has given good behavior for interaction screening. At this stage, I would like to run through the main points. We proposed an algorithm that uses a preliminary slicing fusion step before applying the KEF method to perform interaction screening in height and ultra-height dimensional regression models. Our algorithm has been implemented on R with data generated according to 3 different scenarios, and the process has been repeated 100 times to guarantee a good performance study. Our approach enjoys the sure screening property and is theoretically robust and computationally feasible. In a future work, we aim to extend the experimental study to both simulated and real data. The following listed references were used in this work. Thank you very much for your attention. I'd be happy to answer any questions.